So, Sikal students, so let's have lecture number 3 on systems of particles and rotation motion. So, this is continuation of second lecture. In order to understand this lecture, you must refer to the last lecture. So, students, yesterday we have defined that the relevance of, to some extent, the relevance of center of mass. So, we have defined this equation m1, we have in fact derived this m1 plus m2 total mass into r vector, which is the position vector of supposedly the center of mass, is equal to, anyone knows, any student, is equal to m1 r1 vector plus m2 r2 vector. This r1 vector is a position vector of m1, r2 vector is a position vector of m2. Okay, so we have seen position vector of center of mass. Position vector of center of mass of two particle system is such that the product of total mass of the system, the product of total mass of the system and the position vector of center of mass, position vector of center of mass is equal to sum of product of masses of two particles and their respective position vectors. All right. So, students, from here we can understand very important uh, things. Number one is, you see, this shows, this equation exactly shows what is the concept of the mass. We've already seen, in case there is a circular ring, center of the mass is in the center, but actually there is no mass here. But whatever is the effect of forces on every particle in this, the net effect is given by the resultant of all these forces acting on center of mass. Like we discussed, F was the resultant of two forces. Last time we have seen one force was F1 vector and the second force was F2 vector. So whatever is the result effect on this 2 point system of these two forces, it is equivalent to a single force F, which is the resultant of F1 and F2 acting on the center of the mass. This is the first understanding we have got. What is the second understanding? So you see that the derivation, this derivation shows that the concept of center of mass, the motion of total mass of the system is described under the effect of external forces only. Under the external forces only. What's this means? This means the internal forces, means force between these two particles. This particle is 1, this is 2. The force, gravitational force because of 2 on particle 1, we defined as F12, and gravitational force on particle 2 because of particle Fn1 was F21. So these two forces are equal and opposite in nature, hence they cancel out. So the net effect is the under the effect of external forces only. Third point, students, imagine if the center of the mass of two particles were at the origin. The center of the mass was here, right? The line joining M1 and M2. We're going to prove this also, that the center of the mass of 2 point system is always on the line joining M1 and M2. Okay. But then apart from this, if this C is at origin, if this C is at origin, then students, what immediately we can say, the position vector of center of mass obviously will be 0, right? So from the equation, what do we get? This becomes 0. So we can say m1 r1 vector from this equation. This entire thing becomes 0. m1 r1 vector is equal to minus m2 r2 vector. This is going to tell us a very important thing, students. Just see r2 vector, position vector of point mass m2, is equal to R2 vector is equal to minus M1 by M2 into R1 vector. Fine. What is it show? Imagine. One is that if R1 is negative, if R1 is negative, R2 will be positive. Interesting. It will be positive. Means the position vector of first point in case it is negative, right? The position of the second vector is always positive. Okay. Now the next thing is you can also say that if M1 lies on left side of the origin, okay, and what is origin? Origin is center of mass, Cn. Then M2 will lie on the right side. So from this, we can make a judgment that center of the mass of two particles lies always on the line joining two particles, right? This is M1, this is M2. Another thing, students, just see if M1 is greater than M2. Okay, we just see that if this is 10 and this is equal to 4. So if I want to make 4 equal to 10, I have to multiply 4 by a greater number, right? But if 10 is equal to 50, right? So I want to make 10 equal to 50. I have to multiply 50 obviously by a number less than 1. This is a simple funda of mathematics. So if M1 is greater than M2, right? You just see M1 greater than M2. What you will get M1 greater than M2, R1 vector would be less than R2 vector. What is that? The center of mass of two particle system lies closer to the heavier particle. So see that, students, suppose this is a, this is one particle. This is, let's say, the mass is quite bigger as compared to the second mass, M2. The center of mass will get drifted towards M1. From this, I can also say that in case the masses are same, M1 and M2, the center of the mass will exactly lie in the, any student? If these two masses are same, the center of mass will exactly lie in the center, right? So this we can prove it also. You just see the fifth point. When the two particles are of equal masses, that means M1 is equal to M2, let's say that is equal to M, let's say, right? So what do I get? I get M1 plus M2, that is M plus M, and 2 position vector of center of mass is equal to M R1 vector plus M R2 vector, right? To take M common, it becomes R1 vector plus R2 vector, right guys? This is 2M. R vector M cancels with M. So you see that you get R vector is equal to position vector of first point, position vector of second point divided by 2. Where does this R lies? It lies in the center of them, right? So these are important things, like if this is, let's say, first mass, and let's say this is R1, this is second mass, this is R2. So if M1 is equal to M2, number one, it's lies at the center of mass lies on the line joining one and first and second point. Second, it will be in the center of them. All right, students. So this we have done. So based upon this, let's do a small numerical also. It says find the center of the mass of carbon monoxide. Okay, carbon monoxide molecule. We have carbon and we have oxide, oxygen, two atoms. It says find the center of mass of carbon monoxide molecule of bond length B. So bond length is CO, bond length is B. Okay. So find the center of the mass of carbon monoxide molecule of bond length B. So you see that, guys, we know that now in this case MC by MO. Mass of carbon atom, mass of oxygen atom, we'll talk about chemistry and all. So this is it will be 12 by 6. Talking about the, you see this is atomic mass, right? 12 by 16. So this is equal to 0.75. Or you can say this is equal to 3.3 by 4. Right? So now you see, guys, how do we do this? Let's say the center of the mass. Now, what will you say? Carbon is 12, right? And oxygen is 16. So it will be drifted towards oxygen, right? Oxygen is heavier. So let's say this is x distance, and so this distance will be d minus x. So applying that equation, you will get the sense. So mc carbon into x would be equal to mo d minus x. So from this you get x is equal to 4 by 7 d. So this is the understanding, students. This is the understanding we have derived from the equation we have derived from system to particles. Right now, guys, we're going to discuss what the center of mass. We're going to extend this. Might not have much difficulty understanding this. Center of the mass of the system of n particles. So initially we were talking about two particles, right? And now we have so many particles, right? And all particles moving in some velocities, and now we want to find their center of mass. Okay, number of particles, same number of velocities. Okay, so we're going to just generalize the results, right? So now we believe that, you see, Ri vector. Now we believe Ri vector is a position vector of a particle having mass mi. Am I right? So this is like ith particle, ith particle. So obviously, so if it is like third particle, R3 vector would be the position vector of m particle having mass m3. Okay. So now the position vector of center of mass. Position vector of center of mass in two-point system. You remember it was m1 r1 vector plus m2 r2 vector divided by m1 plus m2 total mass, right? So this will be the same, can be generalized like summation, call it sigma, summation I is equal to 1 to n. How will I write? Yes, Ishma, can you tell me what was the expression here? Generalize that m1 r1 vector plus m2 r2 vector. If it is n vectors, how will you generalize? What will be the expression here so that I get m1 r1 vector plus m2 r2 vector plus m3 vector? So how do I generalize? I will write m I, come on, then r I
vector by
vector.
I plus
Summation I is equal to 1 to n. Yeah, can you tell me? नीचे क्या आएगा?
mi.
So it will be, yeah. So it's saying you're right. Mi. So fine. So this is like total mass, and this is summation of all these terms, right? So there are like, let's say n terms, so I will reach till n, right? If there are 10 terms, there'll be 10 terms. M1 R1 vector plus M2 R2 vector plus dash 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 plus M10 R10 vector. That's all. Okay. So guys, now let's say this equation. Okay, we have already derived 11 equations. So let's say this equation is 12. Okay. So from equation 12, I can always say R vector is equal to what? The summation I is equal to 1 to n m I r I vector divided by, what is this? This is total mass. Can I write total mass by m? Where m is equal to m1 plus m2 plus m plus mn. Am I right? Okay. So now guys, see, this is the constant. So can we say that this is a vector sum? Hello students, this is a vector sum. A vector x, if I multiply vector x by k, this is also a vector having magnitude k times magnitude of x. We have learned that in previous class, in this class also, in vectors. So the right side of this equation is a what? It's a vector sum. Now let's imagine, let's go to the second page. So let's imagine that what? Now we want to talk about the now we don't want to say we don't want to assume that all these points are coplanar. They're in one plane, xy plane or yz plane or xz plane. No, they are in space. So they need not be coplanar. And if they are in space, then we want to talk about three dimensions. Space is three dimensions, right? So we talk about x-axis, we talk about y-axis, and we have z-axis because then the point can be anywhere. All right. So when the point is anywhere, any student will tell me, especially I want to ask Ishma, if there's a point in the space, how many coordinates do I need to specify this point, beta?
3.
Three coordinates, so it will be x, y, z. Am I right? This will be the coordinates of any point in the space. Am I right? So ith point, first point, let the coordinates of first point be x1, y1, z1. Coordinates of 10th point be x10, y10, z10, right? So I can say what? xi, yi, zi. So these are the coordinates. These are the coordinates of the point. All right. So this is which point where our ith particle is there, right? Or where ith particle is located. So what will be the position vector, students? Ri position vector, if you remember, is sum of the individual components x, y, z. So we can always use the unit vectors I cap along x-axis, x, I. Can you complete this, please? What is the unit vector along y-axis? I cap, then j cap, unit vector.
J cap.
Here, come on, y, I, right, plus along z-axis,
J cap.
here, z, I. Beautiful. That's great. Now these are the coordinates of any point, right? So it means that if there is a third point, so how will I write this? So it will be R3 vector would be equal to I cap x3 plus blah blah blah, right? Now, so that means I have taken into account the coordinates of all the points, right? Right. So now what I want to tell you is that now we want to talk about the coordinates of center of mass also. Last time we had taken C. So whatever you take, so let's say the coordinates of center of mass are x, y, z. Be the coordinates of center of mass. I just write it at CM of the system. Center of mass. Center of mass kiska? Not mine, not yours. Center of mass of the system of how many particles? Of all the particles and particles, right? So now what we can write? So what will be the position vector of the center of the mass? Would be equal to, come on guys, would be equal to I
Vector I X
x.
plus Y J
My question,
O J K
so should I write xi or just x?
X or X.
No, you're very right. I will not write xi because x is fixed. It's a single point. I,
Yes, sir.
I because this is representing so many points. I will not write xi. There's a student near me who's telling, should we write xi? No. So plus it would be j cap y plus k cap. This is the coordinates of the what? The coordinates of the center of the mass of the system. Very right. So now from this equation, from 13th equation, from this equation, this is 13th equation, we can write what? What, students? So we can write that I cap x plus j cap y plus k cap z. This is what? This is representation of R vector. What is that, Ishma? R vector, capital R vector. R vector is the,
Center of mass of system.
it's not center of mass, baby. It's the, it's the position vector of center of,
Direction
right?
of
Also, okay, is equal to 1 by m will come out. Summation I from 1 to n, right? What? N I, and then what? Can you tell me? It will be I cap. Come on, student. The more you speak, the better you are. Xi plus. Come on, Ishma, speak. I plus K cap Z I. Am I right? Okay. So now, if you equate x, y, z components of both sides, can anyone tell me what is x? Just equate the component 1 by m will be associated with all. 1 by m will be associated. What will be x? X will be 1 by m. Can you tell me? It will be summation. See, when
Xn.
summation will be attached with everything. So I is equal to 1 to n. What? Can you tell me? It will be m I. Come on. X I. Right? It's understood. I cap is there on both the sides. Right? X is equal to this. Now, Ishma, can you tell what is y equal to? Y is 1 by
1 by m into
I
summation I is equal to 1
from
till
1
n
n. Correct. Very good. M I
m I by j cap.
z is equal to 1 by m. Summation I is equal to 1 to n. Come on, Amitoj and Arjinder. M
M is
Z
Z.
M I Z. Beautiful. Very good, students. All right. So okay. So guys, where we were. So now, so you see that the number of particles, atoms, or molecules in a rigid body of finite size, they are very large. Millions of, if it is a compound, there are millions of molecules. Let's say it's a compound like carbon dioxide, there are millions of molecules, billions of molecules. If it's just a element, let's say it's magnesium. So you have millions of atoms of magnesium. So it's not really possible to, take care of individual every particle in that, and then see its location, its coordinates, and see the force analysis of every effect of force on every particle. It's not really possible. So now, see, very important. The spacing of particles is very small. They're closely attached, especially in metals. So we can treat the body as a continuous distribution of mass. We'll treat the body as continuous, even if it doesn't have. Even if it doesn't have, we'll consider it continuous distribution of mass. Might relate it to a synonym homogeneous, right? So now we are going to divide the body into n small elements. This is the way we do it. We're going to divide the whole body into n small elements. Why I divided into n small elements? So n particles. So every particle, related to this one element. You got it? So every element would have, let's say, delta m1, then delta m2 till delta mn masses. Right? Now, ith element of mass, ith element of mass, how much? Delta mi is located about the point. Which point? Ith element of mass delta mi is located about which point? Can you tell me, guys? Xi, yi, and zi. Okay, so fine. Now the coordinates of center of mass are approximately given by coordinates of center of mass are approximately given by what? X is equal to 1 by m. Just a knowledge from whatever I've derived before. Summation, come on guys, I is equal to 1 to m. So it is delta m1 instead of m1. I've taken the mass of the element, delta m1 xi. I'm sorry, not m1, m1, mi. So what is y? Y component of the coordinates of the center of mass, 1 by total mass. Summation I is equal to 1 to n delta m I. Come on, students. My I and z would be equal to 1 by n summation I is equal to 1 to m delta m I. What? Come on. Z I. So see, if n is bigger, students, the bigger is n, I take more and more elements, more and more particles. So delta m1 would be, students, if I divide, let's say a block of iron into, let's say, 1 million parts, there'll be some masses. If I divide it into 1 billion parts, the mass will decrease or increase. The more is the number of
It
parts,
will decrease of that.
will decrease, obviously, so that the total mass is same. So delta m would be smaller and smaller. So these expressions would become exact, right? So now we will denote the sum over I by integral. Now this is the way we will use integrals. Why? Because you see, when we say integral x dx, so this we are taking as infinitely small, right? So the sense is converted here. So I will say that what is my, what, I'll go to the next page. So students, what is my summation delta m I xi? So it's like infinite, is so many particles, right? So many particles, right? Billions and millions of particles. So like I could integrate. I use the integral. So it will be integral what? Integral x dm, right? So like differentiation, talk about differentiation, its rate of change, small variation as delta t approaches zero. So you reduce the variations, exactly to, like no variation, when delta t approaches zero. But the integration is exactly opposite. You have small particles, and then maybe small area, then you add them over, to some limit, 0 to infinity, 0 to whatever it is, dx, right? So similarly, I get summation delta m I yi, that's a sense of integration, is equal to integral y dx. And similarly, I get summation delta m I zi is equal to integral z dx, right? So from this, I will get what is the coordinates of center of mass. Coordinates of center of mass is what? X is equal to, come on guys, 1 by m integral x dm. What is y? Please speak. 1 by m integral. Come on, students.
Y dm.
Y dm. Small mass, very small mass for an element dm. And z is equal to 1 by m. Come on, integral z
Z dm.
m, right? So this complete thing x, y, z can be put together in the vector expression. I can say this is the position vector, representation of position vector of center of mass is equal to what? 1 by m, what? Integral. What will I get, students? Integral of
X y
dm. Just representing putting all these three together into this form. All right. So guys, one more thing. The center of the mass, again, if it lies at the origin, let's say center of mass. I've seen that in 2 point system, and now I'll assume center of mass lies on origin of the Cartesian system, coordinate system. So then what R vector is x, it is y, it is z would be equal to, come on students, see that when you had 2 point system, this was your first point, this was your second point, the line connecting these two had point C. So this was your R. And now they say it's at origin, even if you have so many points. What will happen? This is equal to origin, this is equal to 0. So then you have just expressed R vector as what? 1 by m R vector dm is equal to 0. So from this you will get m goes to 0. So integral R vector dm is equal to 0. So with that we can always say integral x dm is equal to integral y only when the center of the mass lies at the origin. Integral z dm is equal to 0. Right? This is fine. So till this, I wish you see the video once again, revise it, take down notes, and don't forget to subscribe our channel. Learn CBSE. Thank you very much, students. Tomorrow we'll get collected and we'll do some sums on this and we'll have more understanding about this. Thank you very much.